Welcome everyone to section 5.6, which talks about the average value of a function. Today we're starting off a little bit differently. I just want to show you a pretty cool tool. Alright, and if you have any questions or if you would like to know more about this, I would be more than happy to send you over some information. But I'm using a software called Maple, and it is a computing software specifically for math. So it's essentially a superpower calculator and can do some amazing things. One of which is do some really cool graphs and animations. And I am logged in to my desktop in my office over on campus. So Maple is a paid software and the university has it installed on their desktops in offices and also in the computer lab rooms and things like that. And so in order for me to access it from my laptop at home, I can go ahead and virtually connect into the computers in on campus. Anyways, so that's where I am right now, but I wanted to show you really quick. So we're talking about the average value of a function, okay? And before I write it all out, it's just like you would imagine taking the average of a few values. So if you have 5 values, you add them all up and then divide by the numbers of value that you had, which was 5. Okay? So in the similar case, if you have the average of a function, you're going to take the function points at every single point and add them all up and then divide by the number of points. And so we're going to represent that by an integral. But we can look at it graphically as well. So over here on the left-hand side of my screen, I have the graph of this function here. It's a third-degree polynomial, okay? And the average value of this polynomial can be calculated to 12.66. And so what I have set up here is an animation to watch this function turn into its own average. So I'm going to go ahead and hit play here, and we're going to watch it level out. All right, so this is how we are going to visualize the calculations that we're going to do in this section. All right, I'm going to play it one more time just for the fun of it. So it starts out at the original function and it levels out to its own average. Again, if you have any more questions or if you think this is really cool, let me know and I'll see what else I can come up with for the remainder of our class. Alright, so back to what we actually need to get to. So we just watched an example of how the average value works, but we still need to know how to actually calculate it. So here we go. If we want to find the average value of a function f on an interval from a to b, then we need to take 1 over b minus a and multiply that by the integral from a to b of our function. And like we already made a comment about, essentially what this formula is doing is adding up all the data points and dividing by the length of the interval. Okay? So let's go ahead and perform an actual calculation. Let's look at example number 1. We want to find the average value of this function here. All right, so we have a linear function on the interval from 2 to 5. So setting up just how we learned, the average of this function is going to be 1 over b minus a. b minus a. So 5 minus 2 times the integral from a to b. So from 2 up to 5 of, big parentheses, 3x plus 5, close parentheses, dx. Alright, so simplifying this down a little bit, we get 1/3 of our integral is going to be our average value for this function. So let's go ahead and plug our integral into our calculator. So we get 1/3 times 46.5, which gives us 15.5 as our final answer. And so that's all we need to do to find the average value of a function. Let's do it one more time. Now we want to find the average value of a new function on 1 to 4. So we have the average value of the function is going to be 1 over b minus a. So 4 minus 1 times the integral from 1 to 4 of our function square root of x plus 1 dx. Again, we end up with 1/3. It's just a coincidence here, but 1/3 of the integral 1 up to 4 of our square root of x plus 1. And if we plug this integral into our calculator, we'll get 1/3 times 5.57. And so our final answer, the average value of this function, is 1.86. All right, so example 3 is the population for a city after 2015 can be tracked by the following function. So this function given here, where t is in years since the year 2015. Find the average population of the city between the years 2016 and 2021. All right, so we want to find the average value, the average population, all right, which is going to be 1 over b minus a. Well, we need to find b and a. We were told between the years 2016 and 2021. All right, where t is in years since 2015. So 2016 is 1 year after 2015, and 2021 is 6 years after 2015. So that's our interval here. So our b minus a is 6 minus 1. And then for our integral, we go from 1 up to 6 of our function 124 e to the 0.5 t dt. Okay, so we end up with 1/5 times our integral, 124 e to 0.5 t dt. Again, we can plug this into our calculator and we end up with 1/5 times 4,572.33, which gives us 914.47. So the average population of the city between 2016 and 2021 is 914 people. All right, now we're going to do something a little bit different. Here we're given a graph, and we're still asked to find the average value of the function on the interval 0 to 8. So 0 to 8. Okay. So we know that we need to find the integral, which is the area between the function and the x-axis, right? It's our total area. And we also know that we can do that by counting boxes, right? So we weren't given the function here, but we're given the graph, and we can go ahead and count some boxes. Another thing that we can use in this particular instance to our advantage is we can use the area of a known shape. Here we have two different triangles, triangle 1 and triangle 2. Okay? And we know that the area for a triangle, is 1/2 base times the height, right? Okay, so if we want our area for triangle number 1, it's going to be 1/2. Well, what's the base? The base is 6, has a length of 6. So 1/2 times 6 times, well, what's the height? The height is right here, which is 3. So the height is 3. So 1/2 times 6 times 3, we get the area of the first triangle is 9. Okay, so then we need the area of the second triangle. So similarly, we need 1/2 times the base. In this case, the base is between 6 and 8, so the base has length 2, times the height, which is 1. The height is 1. So we just end up with an area of 1. All right, but we've learned about signed area, right? So our total area is going to be area 1, counted positively because we're above the x-axis, minus area 2. Okay, so we have 9 minus 1. Our total area is going to be 8. 8 units. All right, but that wasn't the question we were asked. We were asked to find the average value. So we found the total area, but now we need to find the average value. All right, to find the average value, we need to divide by the length of the interval. The length of the interval is our b minus a. So in this case, b minus a is 8 minus 0, which just gives us 0. So the average value is going to be our total area divided by the length of our interval. So our average value is 1. And so if we were asked to graph the average value of this function, we could go in here and say this is the average value. This line right here. And so if we think about our animation that we saw at the beginning of this section, and we could see our triangular function averaging out to that blue line at +1, that makes sense to us, right? One more thing we can make note of is we expect the average value in this case to be positive, since there seems to be much more positive area than negative area. All right, so if we were asked to pick the graph with the corresponding average value, or what is a possible average value, something that is positive or negative should be something that you're looking for depending on the graph that you're given. So in this case, we would expect it to be positive. Okay, let's see, where's example 5? There it is. We have a store called Radios for You, and they have a rate of sales represented by this very long polynomial here, okay, where t is in months since January 1st. So part A asks us to find the total sales during the first half of the year. So the first half of the year, t is in months, so we need the total change, right? We need an integral from t is equal to 0, that means starting in January 1st, up to t is equal to 6. That would be the first half of the year, right? Then we need the integral of our polynomial, so t cubed minus 12t squared plus 16t plus 100. Cap it off with our dt. Oops, there we go, dt. And if we plug this into our calculator, I get 348 radios or whatever units we're dealing with here. All right, part B asks us to find the total sales during the second half of the year. So we need an integral again, but this time starting at t is equal to 6 and going up to 12. So that would be the 6th month through the 12th month. So the second half of the year. We use the same function inside though, so t cubed minus 12t squared plus 16t plus 100 dt. And our calculator says we get 276. So part C asks, what are the total sales for the entire year? Well, we found the total sales for the first half of the year and the second half of the year. So the total sales for the entire year would be the sum of the two. So our total sales for the entire year are 348 plus 276. And so our total sales are 624. And lastly, we need to find the average sales per month during the year. So this would be our average value. All right, we found the total number of sales throughout the whole year, but how many per month? So our average sales is going to be, well, we could go ahead and do a whole new calculation, or we can just say we found the total, which was 624, and we know the length of the interval was our 12 months. So divided by 12. And this gives us 52 sales per month. So we have an average of 52 sales per month. All right. So that is the end of section 5.6 and the end of chapter 5. So do remember that you have your third exam this coming Thursday. So please be studying for that. This is the last section that will be on that exam. Also, don't forget to take your comprehension quiz, and if you have any questions, please send me an email. I'll see you in the start of chapter 6.